On page 39 in our workbook, we're going to look at rhombi and squares. So the definition of a rhombus is it's a parallelogram with all four sides congruent. Just like a rectangle had four 90-degree angles, so they were all congruent. It was a parallelogram with equal angles. A rhombus is a parallelogram with equal sides. So let's just quickly explore the properties of a rhombus, just like we did a rectangle. So I'm going to trace two sides of a ruler. And then using the same ruler, I'm going to draw two more sides. This figure that I have formed, A, B, C, D, is a rhombus. Remember, it's also a parallelogram, but it's a rhombus. So A, B, C, and D. I'll verify that it's a rhombus by just showing with the compass that it does have equal sides. So here's side AB, side AB, side DA, DC, and CB are all equal. So it's a parallelogram with four congruent sides. Everything that's true about the parallelogram is true about the rhombus. The opposite sides are congruent, the opposite angles are congruent to each other, and the consecutive angles are supplementary. So what we want to explore are other features of the rhombus. So I'm going to go ahead and draw the two diagonals here, and let's see what we observe about the diagonals of a rhombus. So AC and DB. Remember, in the rectangle, the diagonals were congruent to one another. They had the same exact length. Well, I think it's clear to see that diagonal DB is quite a bit longer than AC, so they're not congruent. Now, in any parallelogram, they bisect one another. So I know that the piece from, we'll call this E, I know that the part from C to E is equal to that from E to A, and vice versa, because it's a parallelogram. But what makes this unique? Well, the corner of my ruler is a right angle, and you can see in this case that the diagonals are perpendicular to each other in a rhombus. They make a right angle where they intersect, so that's one of our special properties. And the other special property is what each diagonal does to the four angles of the rhombus. So with a piece of parchment paper, if I come here to angle A, a pen doesn't want to write on it, and I trace the portion of angle A, the upper portion that's formed by the diagonal and the angle, you can see that it's a perfect fit there. So these two pieces are congruent to each other. We knew angle C was congruent to angle A to start with, and sure enough, it has been bisected by that diagonal as well. And let's just verify that the same thing is true for angles D and B. So there's one portion of D, there's the other, and when we come up to B, we can see that those are congruent as well. So these are congruent to one another. I'll mark them the same, something like that, okay? So those are the two properties of, actually, I guess the three properties of the rhombus. It has four congruent sides. The diagonals are perpendicular bisectors of each other. They form right angles, and the diagonals bisect the angles in a parallelogram. And those statements are right here. The diagonals are perpendicular and they bisect each pair of opposite sides. So a square combines the best of both. It's a parallelogram with all four sides and all four angles congruent. That means that everything that's true about a parallelogram will hold true for a square, everything that's true about a rectangle, and everything that's true about a rhombus. all apply to a square. So if you called this figure a rectangle, you would be right. If you called it a rhombus, you would be right. But the most specific name for it, since it has 4 congruent sides and 4 congruent angles, is of course a square. All right, let's just solve a couple of problems now that we know these properties. So we're dealing with a rhombus in this picture, and the segments that have been drawn are diagonals. However, we've been given expressions for the sides. Side LM is 2x minus 9, side KN is x plus 15, and we just want to find the value of x. Well, we know in a rhombus that all 4 sides are congruent, so we know that LM is congruent to KN. It's parallelogram, so those were going to be congruent anyway. The opposite sides were congruent. That means that their distances are going to be equal to one another. So we can set 2x minus 9 equal to x plus 15. Let's go ahead and subtract x from both sides. 2x minus x, we'll have x minus 9 is equal to 15. And then we can just add 9 to both sides. And we get that x is 24. And we can plug it that back in and check, and we would see that those 2 sides were the same length. All right, so let's see what we've been given about this particular quadrilateral. We were told that it was a rhombus. They've given us the measure of the distance between points A and Z. This is 14. Between Z and Y is 22, and the measure of angle XYZ, which is this portion, is 35. Let's just go ahead and fill in some obvious information. We know both of those were 35 since it was bisected. I know both of these pieces were 14 since it was bisected, and I actually know, since it's a rhombus, that all of these sides are going to be 22. I might need to find more than that, but that's what I know easily off the top of my head. So how far is it between points X and Z? Well, we'll double the 14, and that'll be 28 units. The measure of angle XYZ is the sum of the two 35s, so that would be 70. And as expected, it's asking us to find the measure of WXZ, which is this one. Well, remember that this entire angle is 70, and that entire angle is going to be supplementary with this entire angle. So 70 plus 110 would give us 180. If the whole thing is 110, we know it's bisected, and so each of the 2 angles here would have to be 55 and 55. So this is 55 degrees and 70 degrees. All right, the diagonals of the rhombus intersect at P. If the measure of angle LMN is 75, find the measure of angle KNP. This is the angle in question here. Okay, well, this is a really similar problem to what we just did up above. If this whole entire thing is 75, then we know that this whole entire angle is supplementary to it, and the whole thing has to be, so that whole angle is angle KNM. That angle has to be 105, and then the angle we're looking for is just half of it because we know it was bisected by that diagonal. So if we divide that by 2, we'll end up with 52.5 degrees for the measure of the angle. I didn't do it quite like